Hello, everyone. Thank you for joining us today. We're excited to introduce our project, Moodify, which is a mood-based playlist recommender, and it's designed to personalize music discovery in a more intuitive, emotionally aware way. Our team is made up of Mauricio Cubillos, Roseline Demiscar, myself, Paula Montejo, Sara Moreno, and Angie Salazar. And so Moodify was created with a simple idea in mind, which is that many of us turn to music to match our mood, and choosing the right playlist can sometimes take a long time, so we wanted to facilitate that process.
University students use music constantly, whether it's during studying, relaxing, working out, or just taking a break. But building playlists manually takes time, and scrolling through pre-made playlists doesn't always capture what we're feeling. Moodify addresses this gap. Instead of requiring users to search through endless lists, the app generates playlist suggestions based entirely on the user's mood. Users can either select an emotion directly or tap a short description of how they're feeling. Using natural language processing techniques, our system interprets that mood and finds playlists that align with it. This eliminates the need to manually match a vibe and provides a quicker, personalized listening experience.
Let's look at the system architecture behind Moodify. This screenshot here shows the 5 mood buttons. So we have chill, focus, energetic, happy, and sad that the user can choose, and then the app generates 5 playlists for those moods. And there's also a text box that the user can type how they're feeling and then submit that mood. On the front end, built with React.js, users can choose a mood or enter a description. The front end also handles routing and performs some lightweight text analysis before sending requests to the server. On the back end, built with Express, we manage everything related to Spotify. This includes authentication, retrieving and refreshing access tokens, and making calls to the appropriate Spotify endpoints to find playlists. This two-layer system keeps the app responsive, modular, and easy to maintain. The front end stays focused on the user experience, while the back end handles the more complex tasks of authentication and API communication. This slide showcases the chill playlist. So if they selected the chill mood, then these 5 playlists would appear. And if the user clicks on one of those playlists, a track list of 10 songs shows up with the song name and the artist's name.
Our application uses a modern, reliable technology stack. On our front end, we use React.js with HTML, CSS, and JavaScript. React Router helps with navigation, making the user flow smooth and intuitive. On the back end, we use Express.js running on Node.js with Axios as our main HTTP client for communicating with Spotify's API. This stack gives us flexibility to scale, update, and expand Moodify in the future.
In our first user journey, the user interacts purely through the preset mood options. When they click on the mood button, the app routes them to the page playlist. At that moment, the front end requests a token from the back end. The back end retrieves or refreshes a Spotify token and then uses that token to access the Spotify playlist search endpoint. Once the playlist data comes back, we present it to the user in a clean layout. If there's a problem, the user receives clear feedback instead of being left confused. This journey showcases the simplicity and reliability of our app's core functionality.
One of our main design challenges was choosing an NLP method, which was for the text analysis. And we tested different forms of doing this, such as sentiment polarity scores, but we found they weren't nuanced enough. We ultimately chose pattern matching because it was simple and scalable for our needs, and it gave us consistent results. And another challenge we had was the Spotify API integration, because Spotify tokens expire quickly, so authentication was a challenge. To solve this, we built a dedicated backend endpoint that automatically handles token retrieval and refreshing in order to ensure our app always has access to the Spotify API.
Going further into what Paul said in the last slide, we explored different methods for interpreting mood descriptions. Sentiment polarity scoring wasn't nuanced enough, as it mainly detects positive or negative tone. Pattern matching, although simple, was scalable and flexible. It allowed us to quickly map user expressions to mood categories, so we ultimately adopted it as our primary NLP technique. On the back end side, we created an endpoint dedicated to retrieving and refreshing Spotify tokens. This ensured that playlist search always had valid authentication behind them.
To ensure Moodify was reliable, we performed testing focused on both performance and accuracy. We identified potential points of failure, especially around Spotify API calls, and added strong error handling to protect the user experience. We also tested the mood analysis logic using over 50 realistic descriptions, comparing outputs to expected moods to ensure accuracy and consistency. Overall, our test confirmed that the core playlist retrieval process works as intended.
Looking forward, we have several enhancements planned. We want to allow Spotify Premium users to log in, unlocking features like personalized playlists based on listening history. We also want to improve our NLP by exploring lightweight machine learning models, such as BERT-based text classifiers, for more accurate mood detection. Our future improvements include personalized music recommendations, in-app playlist editing, and deeper integration user preferences.
In conclusion, Moodify provides an intuitive way for students to discover playlists based on how they feel. The app demonstrates strong front-end design, solid back-end architecture, and an approachable NLP component, with lots of room to expand using modern techniques.